Hello and welcome to Cyclum Speakers Corner. We're happy to see you here with us. We would like to introduce you first to the format of the events that is happening. So this is the Cyclum's own way of the knowledge and experience sharing. We have quite an experienced colleagues who are working in the numerous projects and have a very solid experience they are willing to share. And this is one of the sessions that we have in today together with Karthik. We're going to hear more about leveraging Azure Databricks for large and heterogeneous data of sources of data. Before that, let me introduce you briefly to the company, who we are and what we do. And if we can move along to the next slide, please. So Cyclum is the global digital solutions provider. We have been on the market for more than 20 years already, and we unite more than 4,000 professionals all around the globe with 20 plus offices. Our delivery centers are located in Ukraine, Poland, Spain, Bulgaria, Romania, Czech Republic, and Pakistan, and of course in India. In India, we have been present for a couple of years already, and we keep growing, uniting more than 400 professionals already. And we are working in the domains like fintech, health insurance, cybersecurity, and many more. And we have great companies who trust us and who choose us as their providers. Among those are for Fortune 500 companies, like those who are listed right now on the screen, like Just Eat, like eToro, Metro Markets, Mercedes Pay, and much more. And we also have a very powerful and promising companies from the fast-growing organizations around the world who are moving to the IPO stage and who are developing breakthrough projects and are amazing. If we can move on to the next slide, please. So about the culture at Cyclum, you can see some part of our team here on the pictures, and you can see our CEO Raj Radhakrishnan and Jagan, who is our head of Cyclum India. So here in the company, what we value and why we are a great place to stay, we really appreciate and enjoy the way of the soul and spirit that we have in a company. Even though we are an established company with the investors like recognized behind ourselves, who are supporting us, and Dragon Capital being our investors, at the same time we enjoy and have this startup soul where you can create and launch amazing initiatives and projects, and you can make a difference. And we have very mature and solid and powerful colleagues. We have a very high ratio of seniors, experts, and architects, which is amazing. But at the same time, you can still deepen your expertise in Cyclum, and you can still exchange the knowledge both internally and externally. And this is something that drives us forward. And one of such amazing colleagues is Karthik, who's going to be sharing with you his knowledge today. And let me introduce him to yourself. So Karthik is AI and ML consultant at Cyclum and has more than 20 years of experience in software development. He's focusing mainly on data, AI, and ML solutions. And he has been consulting and helping organizations with the end-to-end data solutions based on AI and ML for more than 10 years, and had experience in different kind of business domains, like insurance, like transportation, manufacturing, banking, hospitality. And he is also visiting faculty at Great Lakes Institute, and he delivers corporate learning programs in the same area we're going to be talking about today, data analytics, machine learning, and AI for the large organizations. So that is why he's here with us today. That is why it's worth hearing to his presentation and asking questions and being engaged. Just to give you to answer a couple of the questions we usually get on the beginning of those sessions, we will have the materials that are going to be shared by Karthik today, that we will follow up with you via email and share the slides, as well as we will have the recording of today's session available on the YouTube channel. I'm going to send the link to you, colleagues, after it's been published next week. So please stay tuned for this, and we really encourage you to follow us on social media and to be able to track the following and upcoming events that are happening on a regular basis, like this one. And also, I would ask you to ask your questions in the chat. We're going to have the dedicated Q&A session at the end of the event. The event will last for around 1 hour and a half, out of which 1 hour is going to be dedicated to Karthik's presentation, and we're going to have around half an hour for your questions. So please stay tuned. Please give a warm welcome to Karthik, and we're moving on to the topic that we're having today. Karthik, the floor is yours.
Thank you. I hope you're able to hear me.
Yes, sir.
Thank you very much. Just checking the audio quality here on this. I just want to quickly set the agenda for today, what it is that we are planning to cover. Obviously, this is not a training program on Azure Databricks here. We have plans for a multi-part series. The first part is basically giving you the journey as to the evolution of Databricks as a platform, not as a Databricks company, but as an outsider here. So there's a little bit of a context that I'll be setting in terms of the where AI and ML is as on today. We will look at the evolution of the data platform itself in terms of the journey of data and how things have evolved over the last few decades. We will go back to the definition of a data engineer and who this data engineer is and what are the key responsibilities for that. And finally, we will be ending with what is Databricks and how does it fit in all the things that we cover in 1, 2, and 3. This may not be very exhaustive information on Databricks. Obviously, we are thinking about some follow-up sessions as well. Having said that, let's move on to the first section, which is the background, the context. Now, in the last decade or so, there's been a significant interest across the globe in leveraging machine learning and AI, artificial intelligence in terms of decision making. Now, this has gone through multiple names. People used to call it as data analytics, and then they move on to machine learning. Then they talked about data science. Now everyone wants to tag the word AI as part of everything. So essentially, they are basically overlapping concepts. You have AI, but behind the scene, it's really machine learning. The whole area could be called data science. And then the analysis part of it is data analytics here. So the terminologies start to change, but then there's a fair amount of interest and people have been investing. And you would have seen a whole lot of training programs across the world in terms of AI and ML. But more specifically, in terms of the business itself, there are a number of areas in which they are leveraging. Now, learning and getting caught up in the hype is one thing, but then there is a practical implication of how exactly we apply that in a day-to-day job here. So I had the opportunity to work with a number of organizations who were in the initial stages of their data journey itself. Now, it's not a new concept. It's been there for a long time. But then organizations tend to go through various stages. Now, Gartner themselves have identified 5 levels of AI maturity models here. Just to give you an overview, level 1 would be more of, there is an organization, there are multiple business functions, like there is operations, there is finance, there is HR. Some of these teams might be doing some kind of analysis with Excel, having downloaded information from a ERP platform like SuccessFactors or SAP. And that's really level 1 in the whole engagement. Level 2 could be, there could be some organizations which has some skilled resources in terms of ETL skills, SQL skills, perhaps visualization skills. Maybe there are a few people who knows Python, who knows how to apply machine learning. And essentially, they've started to go into this journey. There is some structure, but not a completely defined model. So that's really level 2. And level 3 would be more of, you have a defined center of excellence within an organization. There's a centralized team which has data engineers, data analysts, there are data scientists, there are different business functions. They have their use cases, how to apply this. They work with the COE and they work as an extended team to deliver AI-based models. It's not fully mature yet, but it's still a place where there are some functions which are experimenting, some functions are matured. So there's a mix of this, and that's level 3. Level 4, if you will, is where organizations have completely disrupted one of their own business function there, leveraging AI ML. And then level 5 would be transformative, where you're actually looking at disrupting the market or competitors as well. Now, there's not very few, probably going to be very few companies on level 5. Perhaps the best of them would be on the higher end of level 4. But most of the organizations that you find in the world are perhaps going to be between level 2 to level 5. Nobody wants to acknowledge that they are in level 1, but I'm sure there are a few ones in level 1 as well. But most of the companies are going to be between level 2 to level 5. I think that context is important because I'm going to make an assumption that some of you are working in IT organizations. Some of you might be working directly with the industry itself in terms of AI ML. So you need to have a context of, before you suggest a solution such as Databricks, you perhaps need to know where your client or your own organization is. And it's important to self-respect that and understand where we are. And in more recent terms, in the last 6 months or so, there's a lot of hype around ChatGPT and your overall GPT models on large language models, which is part of your generative AI. Now, what I've been speaking so far has been on the traditional AI ML. Now we are moving on to the generative AI, where AI engines are far more bold in terms of telling you what needs to be done. Microsoft has introduced Copilot, which is helping people to reduce their time in generating code or even improving the quality of their code. There's a huge jump in terms of the capability. Now you would see a lot of things on generative images as well, and videos as well, and audio. Quite a number of things have come up to a large extent that people are even worried. Are we doing the right thing right now? Should we hold back on some of this development here? So you would have some of the experts, in fact, people from GPT team itself, who went and told that we perhaps need to put a hold on this for a few months until we get the full picture on this, because this is going to be extremely disruptive to the market. Quite a number of days ago, I read an article where a CEO decided to lay off 90% of their employees, especially in the call center area here, and then replace it with ChatGPT for most of the generic queries. So there's quite a number of ramifications. It's an evolving situation that we need to look at closely. But at the same time, we as data engineers, we need to be clear that there's quite an amount of work that needs to be done from our end in order to support this. So that's the key context there. I'll just leave with another story, 2 stories, if you will. The first one, again, this came up in the social media. The US Air Force obviously has denied this. But in one of those simulations, so an operator was training a drone to make targeted kills there. And a lot of times the operator was saying yes or no to some of those calculations that the drone was making. Drone was deciding to kill. Obviously, this is a simulation. Drone was supposed to kill someone, and then the operator kept saying no, no, no. Behave. Now, it went to the extent that the drones decided that the strategy was to kill the operator itself, because that person was not allowing it to complete its objective there. And when people retrained it to say, no, you're not supposed to kill the operator, then it went against the communication tower or the operator who was instructing the drone itself. Okay. Now, keeping aside the authenticity of the story, but then we could essentially believe that it can be true because these are simulations, and I'm sure people are doing this, even if they don't want to admit this. So, few years ago, we were talking about useful model, not useful model, and we were there. We were talking about garbage in and garbage out. And today it has gone to an inflection point where we are worried about, to the point that we are not worried about good or bad model, we are now worried about the dangerous implications of these models here. So now all these models, the AI models that has been built, it basically depends on the data itself. Okay. So how, valid is this data? How ethical is the things that we are trying to do with the data? So the role of the data engineer becomes a lot more crucial in order to enable the right thing here. Okay. Another example I want to share with you, perhaps two versions of the example. So perhaps I missed a slide here. Sorry about that. It was a specific story on, how do you determine the quality of oranges based on drones and all of that. Perhaps I'll talk about that in a subsequent slide here. So I'll move forward as this story here. Now, the key elements of this is the success and failure of your AI models. It depends on the data. Now, in this world of disinformation, where there's a lot of conversations around, if you look at the political parties, the kind of message that they are throwing out in the web and social media here, a lot of them are false statements. Now, if you look at your own WhatsApp messages, apart from the jokes and the memes here, a lot of the message that is coming through, maybe 60-70% of them tend to be incorrect messages there. And if you're building your large models, language models using this kind of data here, obviously what the AI engine is going to learn would be extremely biased, a lot of them dangerous as well. So there's quite a number of things that needs to be governed in terms of how the models are even being built here. So I'll just leave those two thoughts with you. In terms of, before we jump into your Databricks engine or your AI or ML engine here, we need to understand the context where we are getting it. There's a number of challenges that we are looking at overcoming as part of this journey here. Now, in terms of data analytics or machine learning, it's not a new concept. It's been there for many decades. People have used statistical techniques. Neural network has been there for quite a long time here. But there is something fundamentally that has changed in the last few years. Okay. Now, there are three elements that has changed, and I'll explain those three elements with one example here, perhaps another example next slide. Now, if I take the insurance industry, 10 years ago, 15 years ago, if you were to get a new premium on a car that you have purchased, the amount that you have to pay as premium for getting an insurance policy depends on a number of parameters. Number one, it depends on the car itself or the vehicle itself, how long it has been driven, how many mileage it has done. So what are the safety features that it has? Is it 5 doors, 6 doors, depending on the car itself, how big it is, how expensive it is, all of that, and where does the spare parts come? Because if there is an accident, the insurance company is liable to pay for the claim. So obviously they want to know how much it is going to cost. The second element that they look at is you as a driver, because you might be a young driver, you might be an old driver, you might be married, which means that you're probably going to be more careful when you're driving around. So how many tickets you had in the past, how many accidents you have in the past. So they look at two major parameters. But there is a third parameter that they also look at is how exactly are you planning to use the vehicle itself, right? Now, perhaps I drive to the office and come back every single day. Perhaps it's 10 kilometers or 10 miles one direction, 20 miles per day. And I don't work on weekends. I may travel on weekends. So the idea that the insurance company gets is, okay, this is a person who probably travels about maybe 1,000 miles a month, as an example here. So the likelihood of an accident for that person is going to be much different from somebody who's driving, let's say, 10,000 miles per month or 50 miles per month here. Because the more number of miles or more number of hours you are on the road, it means that the higher chance that you may have an accident. So that's the thought process behind it. Now, this was the case maybe 10 years ago. Now, when you have websites like Policy Bazaar, where you have the insurance premium of all your insurance companies in one place. Now people are shopping. They're finding out the one with the cheapest. Now insurance companies are now pressurized to reduce the premium on the vehicle itself because you need to be competitive in terms of the price. However, if you reduce the price, which means that you have less money to invest, which means that you have less profit, which means you have to pay something for the claims itself. So you have less money to play around. So there's going to be cost pressure. So you can't blindly keep reducing the premium just to be competitive. But at the same time, you can't not afford to reduce it because obviously you will lose revenue to your competitors as well. So they figured out a way and introduced a concept called usage-based insurance or behavior-based insurance. There are variations to that, where they, apart from looking at your history and the vehicle history, they want to know how exactly you will drive your vehicle. And accordingly, they want to decide how much discount they want to offer you month on month or year on year. So if you are a safe driver and if you continue to prove that you are a safe driver, then they will give you 10% or 20% discount. Now, what constitutes a safe driver? It could be something like you don't apply too many hard brakes. Now, obviously, in a context of Indian driving condition, perhaps how many minutes you are, pressing the horn could indicate how impatient you are, because brakes and accelerators are a very common thing. So the numbers change, but then you can understand from a US context or a Western, country context, the number of hard brakes are not that often. So which means that makes a safe driver. So you have maximum 3 hard brakes per month or something. And you're not supposed to drive between 12 midnight and 4 in the morning when you are extremely sleepy. So there are certain rules. Now, insurance companies want to know that in order to get that. Now, what they did was they, in every car, there's something called as an onboard diagnostic mode, which is right under your steering wheel. You can just plug in a small device there, which you can get for 500 rupees in Amazon. And you can connect it to your mobile. And that port was originally designed for a manufacturing industry to look at the car performance. But then an insurance company, which is probably in the financial sector, is interested in that data. And with some simple information like your latitude, longitude, time of the day, and your speed, you will be able to determine how fast the person is going, how many times the person is applying hard brakes or hard accelerators. And number of parameters could be got from there that will allow you to determine the behavior of the driver itself in terms of how the person is using the car. And based on that, they are determining, can I offer a discount if you prove that you are a good driver? Now, the key essence of this story is that this data is essentially produced in, let's say, in an automobile sector, which is subsequently being consumed by an insurance sector, which is in a completely different industry. This transfer of data across industries is a key pivotal moment, I would say, in terms of why you are all attending this training, why we have data and analytics as a renewed focus, why Gartner is talking about it, why companies are investing heavily on it. Now, obviously, the generative AI sounds so obvious now, but then one of the key driver for why we are here is essentially the change in the data movement itself across industry. Now, apart from that, the cost of computing has come down. The speed of computing has gone up. Cost of storage has come down. There are other parameters, but one of the key thing is this element here. Because when we go into Databricks, where you're talking about streaming data, you're talking about different sources of the data, different formats of the data, the underlying reason why they have constructed all that is basically the data has started to go across industry, which means an industry which is primarily focused on certain types of data are now getting exposed to other forms of data. So you need the technology infrastructure in order to manage that. That's one example. Another example that we have done in Sikkim itself is for one of the agricultural companies there. We have used drone-based camera images in order to determine the number of oranges which are ready for picking. Now, obviously, if you see this picture itself, even for a human, it's going to be time-consuming, especially things that are hidden behind the scene as well. So using drone, we have done an image capture looking at various shades of yellow here in order to determine oranges that are ready for picking here. So that's an interesting use case from an AI perspective. Now, the key, another variation to this, if you will, is if you look at the agricultural sector itself, and if you look at imagery, and even there are companies which are focused on satellite imagery to look at leaves remotely to determine if there are pests and things like that. There is a meteorological department which has information on weather patterns here. All that can be leveraged by, for example, another financial industry. For example, there are companies which specializes in agricultural loans, and if they're giving to the farmers or to organizations in the agri sector, they want to know whether the repayment will happen on time. These are short loans, short period loans here. So during the harvest season, somebody buys all of that, so they need short-term cash, and then they sell it somewhere else to the mandis. There are lots of sources of data for this, from satellite imagery to government websites, that you want to have the ability to capture and process them. So that is the context for why there is a renewed interest for this and why technologies like Databricks are coming into play, because there's quite a number of things that you have to process. Okay, so now that we have talked about the context, a little bit of a background on the why part of it, now moving on to the data itself, there are a couple of challenges with data itself that we must acknowledge. Now, these are obvious things, so you would have heard about this number of times, but just for the interest of it, I just wanted to cover that. The first part of it is data quality, which everyone talks about. You perhaps have already known about it. This is the data that has been given to me. Is that consumable? Should I do some kind of a cleanup? What kind of challenges there is going to be? The second thing is the volume. Now, the volume is interesting in the sense that a company's data volume can think that it is actually high, but in a different company context, it may not be so high as well. So every company has got its own definition of what is big for them, what is not big for them. According to the industry, we have to work that out. Third, but not the least, is basically the relevancy of the data itself. Now, people don't talk about this. People talk about quality of data, and they talk about volume of data. They talk about veracity, value, and all of that when you look at big data concepts. But the relevancy, it looks a little subtle, but it's a very important thing here. I'll talk about that in a subsequent slide as well. But the relevancy of the data, the usefulness of the data is very, very important aspect to consider. So let's quickly go through some examples of this again. The data volume in terms of megabytes, gigabytes, terabytes, petabytes, exabytes, it just goes on and off. And I've given some context around, what it means for many of this here, right? So for example, 1 terabyte is basically 238 episodes of the Friends serial itself that you can do, including the video and the audio aspect of it. Every 2 to 4 years, now I've seen literature where somebody says 2 years, somebody says 4 years, your data volume in the world, the newly generated data volume, almost doubles. Now, the key thing that you have to take into consideration is that most of the data that is getting generated, a lot of it is going to be noise or distraction. There is really a small portion of it that's actually relevant for your business. So the challenge with volume of data is to find the usefulness among the noise without getting distracted. That's the key thing that we want to do. Now, when we work with the organizations, a lot of times we jump onto the greatest solution possible, right? Build a Databricks environment with these kind of clusters, and you need to have this kind of volume and all of that. But take a little bit of a sense check. Maybe if a company is investing in an on-premise environment, it's probably not going to have a lot of options, because you are going to invest on infrastructure. Now with cloud coming in, you have the ability to scale up. Now for a financial institute, when I set up a data warehouse, I looked at the data volume and I determined that for the 5-year horizon, a 250 GB database is more than sufficient for their data analytics solution. Our laptops today come with 1 terabyte. So I told them 250 GB is more than sufficient. Don't waste money on this. And then after even 2 to 3 years, I found that it was only 20 to 30% of the data was even being consumed there. So I think it's important that we take a proper check on the actual data volume. I'm not saying that Databricks is not the solution. I'm just saying before you jump into, is this the right solution? I think it takes some time to get a proper assessment done in terms of the current and future needs of organizations there. So that's something on the data volume. And when we talk about data heterogeneity itself, so it used to be numbers on Excel file, then perhaps a little bit of a categorical variable. So you may do some analysis based on region, based on product type, using pivot table, you might do some aggregation. So that was the scenario. Then we moved on to database. It was still numbers in format. So basically text data was collected. Maybe somebody collects a log report or something, but mostly ignored from an analysis perspective. This was the scenario. Then when web and social media came in, we had large inputs of text data from SMS, from your WhatsApp, from your Facebook, Twitter, kind of comments there. A lot of knowledge which was predominantly in people's mind started to become digitized. And companies who had invested heavily on data warehouse were just wondering, okay, now I have text data, what do I do with this? So the information is already coming in. I don't have an infrastructure to process. So what do I do? So they invested in data lake or a data blob kind of platform, which is your S3 storage and your, Azure blob storage containers there. So they just said, let me dump it somewhere. So they called it data lake. So let me dump it somewhere. I will look into it eventually, but I don't know what to do with it. Right? Yeah. So the text data, people started to do that. Same thing with images also. So we basically recoined a picture is worth 1,000 data points here. A lot of information can be extracted from a picture and a video. A lot more information. So what has happened is the heterogeneity of the data started to move. Now people used to store, in fact, your RDBMS table comes with blob storage to store images, but they were not really processed. Basically, you read image and then you write image. That's pretty much what they did. Now we are trying to extract useful information from image, right? So you could look at image and video, you can look at if somebody is happy or sad, what's their reaction. You can hear the tone of the voice to determine are they pissed off or are they or in the normal mood. So a number of things could be generated. So all these are data points that we could extract from various sources. So the heterogeneity was the second set of problem that it started to present. Now I've already mentioned data lake. So this is the evolution of data here from Excel and text to data warehouse, which is predominantly your RDBMS, to data lake, which is basically CSV, Excel, text, videos, and all the stored on data lake. And then they introduced Delta Lake. Okay, so data lake is a raw storage environment for your raw files, just in CSV format. Let's say you want to make an edit to that file, you read the entire CSV file, make changes, you save back the whole file. Now, if somebody wants to know which record did you change within the CSV file, there's no way of determining it, okay, unless you put it as a separate log file there. But now understand that as a context when we are introducing you to this Delta Lake concept. So the Delta Lake concept is basically a layer that has been added essentially on top of a data lake, where you are able to introduce the asset properties to raw file. Okay. Now, this asset properties is basically what makes a data warehouse a data warehouse. So why did people go into data warehouse in the first place? You are able to determine each transaction, whether it is valid. If somebody is withdrawing currency from one account and putting it into another account, you have to ensure that it is properly detected here and it is also deposited somewhere else. If the deposit didn't happen, but if the detection has happened, then it means that there is a transaction is incomplete here, right? So you have to roll back and then put this money back onto this person's wallet or the SB account here, right? The account, the bank account there. So you need to look at multiple aspects to ensure that there The data, when somebody is writing the data, when multiple people are trying to read it, you ask them to wait until this is completed because you don't want an outdated data to be read from the data. So those are the key aspects of your data warehouse. And when data lake was introduced, it is just dumping yard. So there's no such asset properties there. So they kind of introduce the asset properties there. So they use Parquet file on the backend. You are able to determine versions of the data. So in case something got messed up, you're able to do a time travel, look at history, and then come back. So they added quite a number of layers in terms of Delta Lake, which enabled organizations to do better with the data lake engine. So whatever data lake files are there, you can then start to move them into data lake that allows incremental changes and time travel and number of benefits. What they also managed to do is create an SQL-like infrastructure. So people who are familiar with data warehouse are now able to use data lake using very similar SQL construct to query on files which are behind the scenes stored in a completely different format here. So in terms of the trend from 1970s to 2020s that we have seen this. And that's where your platform such as Databricks is coming into play. Okay. I talked about data relevancy as an important challenge for you. So organizations have two-pronged problems. One, they have lot of data, and at the same time, they don't have enough data. So there's a gap. Okay, so when we work with organizations, and when we ask them this question, do you have lot of data? Do you believe you have a lot of data? The answer is yes. The answer is yes. They do have a lot of data. They have their ERP platforms. They have their data warehouse. There is a lot of data. But then why have they not applied AI/ML so far? Or what has stopped you from really leveraging that to the maximum? Okay. Now, how do you even determine that? Now, when you go into AI/ML and then you determine, this is the kind of information that I need to do the analysis here, then I find that there is a gap in the data that is being collected by the organization, which leads to a separate digitization exercise. I'll give an example of this. Let's take somebody is running a manufacturing floor and they are looking at shop floor productivity, right? So they want to know how productive people are in producing some item in the factory, right? Now, what impacts productivity? Obviously, the productivity of people are going to be up and down. It could be based on their experience, their age, how long they've been in the same industry. Is that a new employee or not? Are they coming from a vacation or not? Is it dependent on the quality of the robots? What was the last time it was maintained? So the number of things that goes into it, right? Now, perhaps one of the key impact on productivity is whether the person had a fight at home before coming into the office, right? So it's a valid question, right? So something that's going on at my home, okay? Perhaps somebody is ill, maybe there's some other financial issue or another issue that I'm facing back at home. That's going to have an impact on productivity here. But that's not a data that will be captured by organizations here, right? So currently, you will find similar graphs in every single industry. When they are trying to determine, how do I improve my market segment or my market share, you will find that organizations are increasingly find there are gaps in the data. While they do have a lot of data, there's still a fair amount of digitization that needs to happen. So that relevancy is basically, do I have relevancy in the data? Which means the relevancy is always related to the use case, right? So data that is relevant for one use case is not. So from a use case perspective, you have to start assessing the quality, the quantity of your data, and then determine, do I have relevant data for my analysis? So this is one of the many challenges. Last but not the least, which you are all familiar, I'll quickly skip through this, is your data quality, inconsistencies, missing, manual entry error, ambiguity in the data, wrong calculations, data system being down for some time that you're not able to access that. So these are various challenges in data. So I'm going to skip through this because these are obvious slide here. Okay. Now, what we have seen so far is the use case or the context. Then I talked about the challenges with data in terms of volume. We talked about it in terms of heterogeneity, in terms of relevancy, in terms of quality. Let's assume that we have fixed all of that, then let's move on to the insights team. Okay. How does that fit in within an organization? So normally, you have your data source systems like your ERP platforms, SAP, Navision, Business Central. You have your CRM systems for your customer relationship management. You have your other accounting systems. You do have external data sources. Data will come in through a variety of formats, whether it's an Excel or CSV, image, videos, sound, all of that. So a data engineer is basically the prime responsibility is for them to translate all that onto your core platform itself. Okay. On the other side of the spectrum, you have your AML, COE, who are basically consuming this data along with the business units there. Business units might directly connect to the platform, or they may come in through the AICM, ML platform. There could be automation, the management, and all of that, right? So I just want to give you a quick structure of this to introduce where the data engineer is fitting in this whole gamut of text here. So I'm kind of reintroducing the data engineer. It's not a new definition, although we never call somebody as a data engineer. We probably call them as a data warehouse specialist or someone. But the role of a data engineer has started to evolve, and it has become a lot more clear in recent times here. Right? So this data engineer is responsible for managing number of things. It is not just the SQL skills or the data warehouse or the indexing or the performance tuning skills that we are looking at, right? Because the data storage structure itself has started to change. Now we have different heterogeneity in the data. We have RDBMS, we have NoSQL databases, then we have this data lake where you have flat images, text and videos here, right? They will have to do a lot of data wrangling. They need to have toolkits, perhaps Python or SQL, in order to clean up the data, transform the data, aggregate the data, and make it really useful, make it easy for the business consumers to do that. So companies used to do that on-premise in their own environment. Now they are looking at learning something on the cloud platform, right? A lot of cloud platforms comes with out-of-the-box features there. So it's not just learning Python, but then how do I leverage PySpark on a Databricks environment on the Azure platform in order to do that? So quite a number of things that they have to do. Last but not the least is the whole data governance itself, right? Now, you want to share the data internally within your organization. You want to share the data externally with your partners. So there should be a lot of governance in terms of, am I exposing the right kind of data to my external users or internal users? Right? There's multiple levels of privacy. There's a row level locking that you have to do. Maybe there's a file level lock. Maybe you have to do data masking. So the whole process around who gets access to sensitive data is one of the key elements. And they need to do all that within the context of a cloud platform, right? When they are dealing with heterogeneous data while also dealing with wrangling and getting the data into shape. The next two slides, I'm going to quickly walk you through it, because some of this might be relevant to you. You may have already seen it. But what I've kind of done is I've listed within a context of Azure, pictorially, what are the things that the data engineer is even supposed to know? You can see that it's quite a lot, right? So they are supposed to learn about SQLs, NoSQLs, data lakes, streaming data. How do you process this? How do you process different kinds of data? So I think some of that I've talked about. Then you have different engines within cloud platforms. For example, Databricks, which is the core of what we are trying to cover today, can be a separate entity within an Azure platform, for instance, or it can also be invoked within the context of just the Azure Data Factory, or it could be called within the context of a Synapse engine, right? So there are multiple companies leveraging multiple, architecture and solution. So there is an element of that you will have to know. A lot of streaming data comes in. A data engineer is supposed to know how to integrate that using an IoT or a data factory. Then you are supposed to manage your source code, right? You have your GitHub, you have your Postman, you have your Visual Studio Code, you have your Workbench software that you have to learn in order to play around with this data, how to query the data, look at the quality checks and all of that. Certain things that you may have to do with the command line interface on an Azure platform to a storage explorer or a data studio, right? And then last but not the least is monitoring, building Billing perhaps is done by a separate person, but then you need to know how your performance is, which is the data that is being accessed the maximum, right? What is the return of the query engine itself? There's quite a number of things that the data engineer is supposed to look at. And I've kind of listed that pictorially. I've represented. Now I've given that in the details itself. Now we will be sharing the slide with you, so I'll not bore you with the details here, but you probably already have an idea on this. Just for the completeness, I have put this. So this data engineer role has refined from just a SQL engineer to somebody who knows a lot more here, and that's where your the skill set is getting refined. Now we have looked at context, journey of data. We looked at the core engineer. Now we are moving on to this platform itself and how Databricks is helping in dealing with one or more of the problems and things I have talked about in the last X number of minutes here. So a Databricks platform. So Databricks is a company who has created the Spark engine, right? So Spark is an improvement over Hadoop. What is Hadoop? Hadoop is the infrastructure that allows you to do big data processing. So when I talk about big data, again, the definition can change. So for some of organizations that I've talked to, for them, if it exceeds an Excel, it is big data here, right? But the typical definition of big data is basically where you can't store the data in one machine. Perhaps you're trying to split that into multiple machines with multiple copies. So even if a machine goes down, you're able to manage it. And then you put an engine on top of that to ensure that you know where the data is stored across different nodes here, data nodes, if you will. Now, that was the Hadoop environment, which was the first introduction. And there is a lot of physical write and read. So they brought in an in-memory process, which is the Spark engine, which is, I would perhaps call it as a higher version of Hadoop, which is again processing multiple data across multiple machines there. And now Databricks is a layer on top of the Spark engine itself, which will allow you to do automatic clustering. They have abstracted it so that it is significantly easier for users to do this, right? There are quite a number of features that they have packed on top of Databricks in terms of, how the clusters are deployed, how you can run job clusters, how you run processing faster, a lot of performance tuning that they have done. And they've also made the platform easier for users, whether you are just doing simple data exploratory analysis, whether you want to leverage AI, perhaps you want to use an AutoML to automatically generate a number of models on the same data using a variety of algorithms and then determine the best ones. All that has been abstracted to the layer. It's more of a click, perhaps a few lines of code that you write, you are able to do that. It's been a leader in Gartner Magic Quadrant, so we don't have to talk about that much. But Databricks is a platform that is able to unify all of that. Now, the key strengths of that is the whole concept of the lakehouse concept. So we have moved from data warehouse, which is RDBMS. We have moved to data lake, which is basically dumping yard, to a Delta Lake kind of an environment where you put a layer on top of that will allow people to access data on a CSV or a database using a simple SQL kind of a format here, right? So that's the lakehouse concept. So they've implemented it. It definitely makes it better for us to deal with the raw file that we have been consuming in the last few years. It's an open platform, so it will allow you to expand much more. There is a Unity catalog, which is an interesting piece. I'll talk about that for leveraging data governance in one place. A lot of security can be put into place. It makes user interface much easier. There's also this Delta Live tables for your streaming data. Right? Now, this concept has been there for a few years. So it's a relatively new concept here. Companies have started to leverage this. But then any major issues or challenges or something is yet to be known. So for now, it looks good. As a production versus preview, you need to take that into consideration. And again, obviously as a concept, people are going to put in alternate solutions as well. They're going to be competitors. So I'll just leave those thoughts with you. So it's a great concept. a lot of new things. It is trying to address many of the challenges that we had, and we definitely see the benefit out of it. But again, the caution is more of, let's not get hyped up so soon until we see a lot more industry use cases, and ensures that we are able to really leverage this platform to its fullest here. So those are the key things there. The architecture itself, again, I'm not going to talk about the architecture. Obviously, you have materials on the Databricks concept, but the key thing that you need to take into consideration is, as a company, if I'm running and if I want to leverage Databricks environment, is my data going out of my control? That's the biggest worry, right? So in terms of the architecture, there is a cloud account, and there is a Databricks cloud account and a customer cloud account. It's basically, Databricks, if you see, there is a control plane and a data plane, right? The control plane is essentially where you are able to manage your clusters, right? It gives you a user interface. Customers are able to log in. There are notebooks there. You can run your machine learning code there. You can schedule your jobs and queries there. You do all that on the control plane. But the actual data itself is on the data plane, right? They are converted and they are stored as data nodes there. The data node itself can be on a customer's cloud platform itself, right? Azure comes with Databricks, so I go configure it. The data is within their platform, so the data is not really going out of the control of the customers there, right? So, and if the customers have already leveraged Datawarehouse and data lake, it's a lot more easier to plug that in, mount the same thing onto your Databricks engine, so that it can be an extension of the data that you have. There's no major data migration that you may have to do all the time, right? That might be scenarios that you have to do. So it's quite easy for customers who are already leveraging cloud platform to get into this platform quite quickly. It's one of the key things that we have to share. In terms of the data movement itself, it's a medallion architecture. So you have your bronze, silver, gold layer. So normally companies who have been dumping the data onto the lake platform, they load it onto the bronze layer, which is where your raw data is present. And then you kind of clean it up, you transform it, you process it, data from multiple sources. You want to put them together into simple layer. There could be unnecessary noise or unnecessary data columns that you want to get rid of. You can do all of that using the Databricks environment, right? So the Databricks environment is nothing but, you run a bunch of notebooks using multiple languages. Predominantly, we use Python and SQL. You run that, and then the data goes into the silver layer, which is a lot more clean. And then you further aggregate it into the gold layer, and that you can use for your business analysis here. Okay? As a case in point, let's say that you want to do a analysis on, if somebody is going to repay a loan, for example, a credit risk example. What is the probability that somebody is going to repay the loan? So let's say you have historic data of people who have paid the loan on time and who have not paid, who have defaulted. That data will be in a specific transactional format, right? So every single customer, there may be repayment cycles. The data will come from customer master. It may come from industry data, depending on which industry or which kind of loan that you're looking at. For example, you might be in the automobile sector. You might be giving a loan like that. So the impact might be on automobile sector movement itself, right? There might be competitor information also. All this data will be dumped into the bronze layer. Then you clean it up, you process it, get it all ready in the silver layer. Then the data that goes into a machine learning model typically has a two-dimensional structure where you have one specific column on whether somebody has defaulted or not, and then you have multiple columns on the input variables that are potentially influences of that. So the format for running a machine learning algorithm or an AI model is quite different from the data that is stored on a silver layer. So basically, you determine what data is determined from a use case layer, and then you determine within gold layer how you want the data for a particular model type there. While your silver layer is still cleaned up data for the most part. There might be a few unnecessary data, but then for the sake of this, we assume that silver is mostly clean and gold is absolutely clean here for you to use that. And this is the simplified architecture. While what you saw earlier is a technology architecture, but this is a simple business architecture for people to leverage on how Databricks engines can be used across this layer. Now, behind the scene, data is still stored in data lake or data warehouse platforms. Okay, so this is how we use medallion architecture. I also mentioned that I'll talk about Unity catalog. So the Unity catalog is an important feature in Databricks here, right? Which allows user management, and it also allows you to do metastore. So what is this Unity catalog? It's just a layer on top of all your Databricks engine. Okay, now let's take Unity catalog does not exist, right? So let's say I have a company where I have multiple business functions. I have a sales unit, I have a finance unit, I have HR. Let's say HR is interested in doing processing on employee records. There is sensitive information, salary details, performance appraisal details, right? There is, family details that you don't want others to look at. So that data might be stored in some data lake engine, in some place. So you need to put a control there. The same information might be sitting in a data warehouse as well, because it is coming in from let's say a HR platform, employee management platform, like SuccessFactors or PeopleSoft, HCM, right? So that is coming in a different place. So you have to put the same policy there, right? So when you have a lot of input data sources and a lot of directory structure in your data lake, every single place you have to go and put the control. Who has access to what information, right? Somebody has access to employee generic information, but not the salary details. Somebody else has got, but then they don't have something else, right? So you have a lot of these data lake, NoSQL, data warehouse behind the scene, where you have to put all your access controls all over the place. And it becomes fairly complicated when you have more and more data sources there. So what Unity Catalog tries to do is, it puts a layer. You can configure users at a Unity Catalog level, right? The Unity Catalog is like an access control at a Databricks engine, and the Databricks is connected to your various data sources. So no matter where the source data is coming from, you have added a layer on top of that to manage your users within Databricks itself. So users can come into one place to determine who has access to what control you want. That's a significant improvement. It's a significant feature that reduces the effort and complexity of controlling access to information. And obviously, what it also means is it can also give you alerts on the data usage, and number of things. It can also help you in delta sharing, right? Now, what is this data sharing? So let's say that I'm on an Azure platform. I have my data lake on Azure. I have my Databricks here. But then there is a partner who is basically on an AWS platform or a Google Cloud platform, somewhere else, or they're just on their on-premise and they want to leverage that information. Traditionally, how will you share information with your partners or other customers? You have your data warehouse engine, you create an ETL job, and then you extract the data, then you process it, then you have to send it through a FTP or some process or an API-based approach to send it to them. Now we don't have to do that, because you can configure that directly on Unity Catalog and just say, here is a person, this is the kind of information that they would be accessing, and I will enable that here. So it goes directly from this platform. So quite a number of improvements are possible using Unity Catalog. And that's the key benefit of using Databricks here, right? But again, it's still evolving. It's there in production, but people are starting to evolve in leveraging this, and we will be able to see that in a few years on the effectiveness of this, or people will go back to an alternate solution here. But that's something for us to determine. Last but not the least, the overall demand for, so you've seen the story of data, the background to data engineering, what are the skill sets, and then I've introduced the Databricks platform for you and how different bits are coming together. See, the overall demand for this space of data engineering, whether you use Databricks or you are happy with just the Azure Data Factory or the equivalent in AWS or a Google platform, or you are just happy with a simple data warehouse or a database for that matter, the demand for data engineering itself is going to go really, really high. Right? It's already high, but it's going to keep going up. So there is going to be a fair amount of and what we are seeing is it's predominantly very high in the financial services industry. So obviously, because they deal with numbers all the time. We are also seeing quite a lot in the energies and utilities companies as well. Healthcare also is seeing quite a lot. And then your manufacturing sector is also seeing quite a lot here. Okay, but the highest being the financial industries itself. Now, it's about 30-40% or something. Okay, see, these were some numbers we picked up some. Now, I'm just giving this as an idea to you, but then the concept of data engineering itself is industry agnostic. Yeah, right. So if you are in a smaller domain, it doesn't mean that you don't have the opportunity to leverage this. I think it is there in your own favorite domain. It's just the amount of data that we are processing, the amount of, the features of Databricks or a platform such as this that you'll be using might vary situation to situation. For example, a healthcare might be dealing more with image kind of information, right? So they use DICOM kind of format in order to store and process image here. So, Databricks does have a feature. I think it's called pixels or something within Python that can be leveraged to that. So you might be more focused on that area within Databricks, not so much in other areas there. So I think domain to domain, there might be some changes here and there. Some of them might just feel comfortable using the streaming features of Azure, not necessarily Databricks. So depending on the industry and how the implementation architecture is, these things will start to evolve. So that's broadly what I wanted to cover. This is supposed to be a multi-part series. So the first thing is to introduce you to what is Databricks and what is leading to Databricks. But then the subsequent session would be, we might go more depth into one session purely on performance improvement within the Databricks. How do you improve performance? Now we would look at AI/ML within Databricks as a follow-up session as well. But for now, I just want to leave this thoughts with you, and I will open this up for any questions. Irina, if you'd like to.
Yes, thank you, Karthik. If you could move ahead to the next slide, please. Dear colleagues, so you have listened to Karthik now, and I'm sure you had a lot of insights and helpful information. Let's move along to the Q&A session. And if you feel like you have any questions, feel free to ask them in the chat here. In front of you, you can see the QR code where we would really ask you to share your feedback about the presentation that you heard today about Karthik and how he delivered the talk and how helpful it was for you and what kind of topics you would like to listen to in the future. So please scan it and share your feedbacks already and don't delay with that. And if you have any questions, Karthik is here to answer them, and feel free either to unmute yourself or to ask the questions in the chat. As answering your questions to those in the chat, let's keep the slideshow, please, Karthik.
Yeah, sure. I just wanted to see if there is a chat window.
I'm gonna read it out, so that's good.
Oh, thank you.
Thank you. So, colleagues, the floor is yours. Answering the question regarding the slides for the reference. Yes, you will have the slides, and they will be shared with you once we have the video published and once we have all the slides available here. We're gonna follow up with all of you. And now, if you have any questions regarding the content that you've seen or something maybe you didn't see and would like to hear, feel free to ask. Regarding the prospects for mid-career professionals, you mean those available at Cyclum, or you mean the role and working with the Databricks as a specialist? Maybe may I ask you to clarify your question? In the meantime, if we could move along to the next slide, Karthik. Dear colleagues, we encourage you to follow our career page, which is here available via scan, where you can track all the opportunities at Cyclum, specific Cyclum Global and Cyclum in India, so that you would not miss any roles that are available for you. And also you can register and leave your application there, and our colleagues from the recruitment team will reach out to you once the appropriate opening is available for you. So we have a couple of questions already regarding the internship at Cyclum in data engineering. We don't have the internships like this at the moment, so there's nothing we can offer to you, because we usually have the specialists or middle plus or even senior plus levels who are working directly on the projects. But we cannot say that we will never have this kind of internship. So we encourage you to follow our pages on social media, and you have them all on in your invitation letters. You have the links to all of those. Feel free to follow us and to check if there's any kind of interesting programs are being opened at Cyclum. And now, Karthik, I would ask you to jump on the answering the questions. So the question is what is the career in data engineering for mid-career professionals?
Sure. I'll give that answer to that. So we have talked about AML, all of that. Right? So people have been talking about ChatGPT and all of that. Right? But in order to do all that, if you don't have the data, nothing is going to work. Your generative models are not going to work without data. Your traditional AML is not going to work without data. So data is the thing on which the whole engine runs here. So data engineering is here to stay, right? Now, and people will continue, it will continue to evolve. So more and more data sources will come in. So you constantly need data engineers in order to process and get it ready for the business users. There's quite a number of translation that we have to do, and that we will continue to see. So you could have the best algorithm in the world, and if you give one column of data, it's not going to really learn anything from that data here, right? So it's not going to do that. So data engineering is a very, very crucial part, and that will continue to exist. So it's going to be quite good in terms of the data engineering itself, right? The algorithms on the other side, right? The relevancy of data scientists are starting to change a little bit, because if you have something called as an auto ML model, for instance. So I can give the data and it runs the best algorithms in the world within a matter of an hour and gives me the output, the insights that I'm looking for. So previously we had data analysts or senior data analysts and data scientists running these algorithms. Now all that is getting automated, but then they can't do anything without the data engineers. So that's why I call them the unsung heroes. So that's going to be quite high in terms of career in data. Internship, I think Irina has already answered that. Sorry, Irina, I have the questions on my mobile, so I can read them simultaneously, just to save you some time. So the internship is not something that we have done in this one. So it may change in the future, like Irina said. I'll move on to the next question. What are the tools to be leveraged for becoming effective data engineer? So I have 2 slides just for that. So the things that you would have to learn, right? Align yourself to a cloud platform, number 1. The most important skill that you require is SQL, right? SQL. Remember this, learn it, right? You could learn something else, Python. And Python, SQL are the 2 important software tools that you need to learn. Align yourself to one of the cloud platform, whether it is Azure or AWS or Google Cloud. These are the 3 big ones in the market. Identify what are the data engineering related toolkits available within these platforms. For example, if you go to Azure, there's something called Azure Data Factory. You must learn that if you want to survive with Azure. Similar one might exist in AWS and Google as well. There is something called Synapse, which is basically a layer on top of your Azure Data Factory. You can learn that, great. If not, it's okay, because you can still with Data Factory. Databricks is an alternative. Sometimes it works along with Data Factory. So these cloud providers come with a lot of options for you. Sometimes it's very confusing what to use when. I think once you start to understand all these individual pieces together, then based on the client requirement, you would know which is the right. So Lakshman Chennai have answered us that question, the tools to be leveraged, as part of this. Okay, Pawan has asked, can I talk? Before that, let me answer the next question. Azure Databricks, this is from Zia. Okay, Azure Cloud Engineering includes Databricks as well as Azure Synapse Analytics or both. Now, okay, that's the course include. Like, this is not a training course here. This is just a knowledge sharing session here. We are not doing a training program here. But to answer your first question, see, the cloud engineering is a common topic. So there's something called cloud engineering, then there's something called data engineering, right? So our focus is on the data part. So when we talk about data, it is all about bringing data from multiple sources, cleaning it up, getting it ready for the business users to process. So that's your data engineering. Now, how you do that? Databricks is one option. Azure Data Factory might be another option. Or I could just use a simple Python script to do all of that on an Azure function on a serverless architecture. So it doesn't really matter, right? So the data engineering is getting the data ready for the machine learning algorithms. So our job stops there. So in that context, whatever toolkit that is at your disposal, if you're able to leverage that and get the data ready, then that's essentially your data engineering. Now, within the context of cloud, I've given a list of examples: Azure Data Factory or Databricks or Synapse. So you could use Synapse without Databricks. You can use Databricks without Synapse. You can use both simultaneously. So that is an option that I want you to explore so that you understand this yourself. Because what Microsoft has done is they created some capability and then they created a capability on top of that. Now people are confused. Should I use this directly or should I use the one on top? But behind the scene, it's all the same. It's just the way that the point of view entering into this, some new features might be available. So it's a good thing to look at all those features. Now, I would recommend go through the material for the Microsoft certification exam called DP203, Data Practitioner 203, right? Now, if you look at the table of content for that, that gives you an exhaustive list of things that you would have to learn if you want to become a data engineer within the context of Azure. If you go through one course, you learn SQL, you learn Databricks, you learn Synapse, you learn Data Factory, you learn Data Lake, how do you connect all that? All that, I think it's an excellent course, even if you don't appear for the examination, but it's an excellent, table of content for you too.
So you aren't providing any training programs, is it?
Go ahead. Sorry, go ahead.
So that are you providing any training programs or?
No, we are not a training company.
Okay,
we are a data engineering company.
So just like we have mentioned in the beginning, so at Cyclone we have a lot of professionals who have a very broad experience, and Speakers Corner is one of the formats where these colleagues are sharing their expertise externally. We're not providing the training programs or anything like that. We do employ some of the colleagues to other projects, real projects with real clients, those that I have mentioned earlier. But we are not providing any internship programs or training programs as per se.
Hi, Karthik. Pawan here. So can I?
Sure.
Yeah, go ahead.
Yeah.
Go ahead.
Thank you so much. First of all, thank you so much for organizing this event, sharing your expertise across not only with the internal organization, proving your expertise with other people outside of the organization. That really appreciate it. Thank you so much, guys, for this. And I work for actually PwC, so I was interested into this event and I've joined this. So even I'm having a similar technology, like I'm also acting as a data lead as well. But it's a completely different technology, like where we have standard traditional ETL processes, clubbing that into the cloud level. How can leverage this as a Databricks, like so we are using some IBM data stage tool along with this integration with other downline tables and sending to the, it's completely on-premises. Okay, it's completely on-premises. We're working on it. But how we can do this leverage in Databricks? Why? Because even on-prem also now we can mitigate this, like migrate this to the cloud as well, like Google, GCP, and any other AWS and all. But can we do all these things in our Databricks? How it would be? That's what I asked.
So, sure. Okay. So the way I would answer this is with a little bit of a caution also. Okay. So if you're using on-premise, if things are not broken, leave it. So I would say if things are perfect and they're running the way it is supposed to work and all of that, I mean, we are not trying to mess things up there, right? I mean, it's already serving the purpose. Go ahead and do that, right? But if let's say that you want to move on to cloud because you see a better advantage of using Databricks, perhaps an issue that you're facing is with performance, right? Or the issue that you're facing is on the data governance. With data on-premise becoming a little bit more challenging to share with your external users, or in an internal. So I'm sure there are number of driving parameters in terms of your requirement itself. Now, Azure Data Factory allows you to load data. I'm using Azure as an example because my expertise is predominantly in Azure, but similar things could be done on AWS and GCP as well.
Yep.
Now, Data Factory has the ability to connect to your on-premise SQL server and then move the same content into the online platform. Now, this is the place where people start to ask questions. Now, when I have a SQL server on a local machine, then where do I move this into on the cloud platform? So first thing is like for like. If it's a SQL server, move the same thing on an SQL server because your queries are going to be faster. You're going to you have the ability to run queries and all of that, right? So the RDBMS is not going anywhere, right? If the data is in RDBMS, continue to be, let that be in RDBMS on your cloud platform. Now the power comes from, apart from the on-premise database that you are trying to move on to the cloud by migrating, what other data sources do I have to have for me to do data analytics and machine learning and AI here, right? So the marketing team might have a lot of data that they're sourcing from outside. So they need to bring alternate data. Maybe, let's say you're in the manufacturing sector, or you're in the fashion industry. So a lot of feedback, customer feedback comes on Twitter or now Threads now, or Facebook or any of those comments. Then you want to process those data, which is coming and hitting you in large volume, which is not going to be in your on-premise database. It's probably going to be directly on the cloud. And you want to mix that information along with the data that you've migrated from your on-premise onto the cloud. Then a Databricks engine will come into play because it allows you to do all those integrations of data on large volume. Yeah, because a lot of times you may want to do an inner join, for instance, and this data that is coming from your Facebook or thing are in a text format. Then you have RDBMS. You're trying to do a join between this and that, and then trying to mix some information together, right? So Databricks has a lot of improvements in terms of joining information from multiple data sources because you create a layer on top of the raw file format, and that makes it easy to manage that information. So to me, take a decision whether you want to migrate all or in part, or just look at the usefulness. So I would say don't start from what is possible to do. Rather, you ask from a business what it is that they are not able to do. From there, if you work it out, then you will know what to move, what not to move, and how to leverage Databricks. What is it? If you don't have multiple GPs of data, I would say don't even go into Databricks because it might be expensive for you to do. A simple data warehouse and a data lake, the data lake cost might be around 1,500 rupees per terabyte per month, right? So that's hardly anything here. An SQL server with 250 GB data would be in the order of about 4,000 to 5,000 rupees per month or something. Because this data is not going to change. It's a one-time read there, right? So you would have options to consider before jumping into Databricks, but I think you need to do that architecture first. That architecture is determined from the use case itself. So work backwards from the use case, you will have an idea of how exactly you want to do this.
Got it. Thank you, God. Yeah.
Sure.
Thank you, Karthik. We have also a question regarding how much club engagement jobs, engineering jobs, my apologies, market would be affected by AI and ML advancement.
We are already seeing the impact big time, right? So all of us are now trying to use Copilot. We're all trying to use ChatGPT and all of that. Okay. So that's the hype portion of it. We are excited by it because we are already seeing something in action here. But let's not forget the traditional AI ML models, which is what the industries will continue to use for a long time, which is for your sales forecasting to, maintenance and all of that. So AI will continue to evolve, and AI cannot be successful without data. So it is a given that any improvement or any advancement in AI ML will have a significant positive impact on your data engineering side. So I hope I'm just making it clear on the data engineering side, it will have a fair amount of positive impact. I hope.
Thank you, Karthik. Dear colleagues, do you have any more questions, maybe?
No, I'm good.
Thank you, Pawan. Thank you, colleagues, for joining, and thank you for being with us today. Just to remind you, we're going to have the follow-up with the slides and with the video available next week. So please stay tuned and check out your emails. We also encourage you to follow us on social media and follow our career page. And thank you all for dedicating your time and being there with us. Thank you, Karthik, for sharing your expertise, knowledge, and addressing all the questions our colleagues had. Please stay tuned for more announcements for the further lectures and sessions by Karthik. And please follow us further and never stand still in gaining new knowledge. Thank you all and have a good day.